So welcome again, everybody, and to these further presentations and webinar on the seismic loss scenario using SELENA, organized by the UNESCO Chair in Disaster Risk Reduction and Resilience Engineering here at UCL. I'm Professor Dina D'Ayala, and I think many of you already met me over this particular channel. So the course that is going on today and tomorrow between 2 and 4 is the 6th or 7th. I hope that you can all see my slides of quite a long list, of course, that we have now been running since April last year. So we will soon celebrate 1 year of broadcasting and training on resilience culture through training program, our program of courses and webinars on techniques, tools, and methods to improve resilience engineering and to disseminate resilience engineering worldwide. This is, as I said, the 7th or 8th that we are running during this year, but nonetheless the less important. And in fact, today we were going to look at seismic losses. In previous seminars, we have looked at the how we compute fragility, how we identify exposures, how we bring this together into risk. And today we will concentrate, tomorrow we will concentrate on tools that allow us to determine a loss scenario at territorial level using Logic Tree approach. The courses, as you know, you can find them all online, past, present, and futures. If you go to our website under the educational activities, and there you can find on our website many other resources also related to our research activities that is ongoing together with the UNESCO unit in disaster risk reduction in Paris. The seminar today is focused on the application of SELENA to loss scenarios. And we have two very good, sorry, this keeps jumping. We have two very good speakers. First, Dr. Abdelghani Meslem. Dr. Abdelghani Meslem has gained a PhD from the Chiba University of Japan and is now a senior research engineer at NORCER and also linked to the Norwegian University of Life Sciences where he's an associate professor in structural dynamics. Dr. Abdelghani Meslem worked with us at UCL on the global earthquake model project, particularly on the vulnerability assumption part of it. And then since moving to NORCER, has extensively been working in cooperation with Professor Sergio Molinas Palacios on SELENA's and its application in a large number of different projects, and they will be presenting this afternoon. Dr. Sergio Molina has a bachelor and a PhD in physics by the University of Granada and is a full-time lecturer at the University of Alicante, where he's also member of the Earthquake Engineering and Seismic Risk Group at the University of Alicante. He has several research line and activity in seismic hazards and seismic risk, and collaboration with a number of different universities worldwide, in part currently also a program with university in Southeast Asia, of which possibly he will mention something later on in the talk, but he has a long-lasting collaboration with NORCER, which has led to the development of SELENA. Before we start the code, this is the program which we'll see us together today for 2 hours, and tomorrow at the end of the presentation, we will also, towards the end of the presentation, we will also have a panel discussions with 4 reactors. Dr. Arianna Guardiola Villora from the University of Valencia, Dr. Dexter Sumailo Lo from Xavier University in the Philippines, Dr. Dominic Lang from from the Norwegian Geological Institute, and Dr. Yogendra Singh from ITT Kampu. But before we move on to the course, just very briefly, if I manage now to get the slides to move, I mentioned a couple of weeks ago, for the ones of you that were online, the disastrous Turkey-Syria earthquake that occurred between the 6th of February 2023 and the 20th of February 2023. This series of earthquakes, and here you have a map of the level of damage caused by that earthquake and the extent of the damage caused by that earthquake. The EFIT mission, the EFIT is the earthquake engineering field investigation teams that is affiliated to the Institutional Structural Engineers in the UK, but has an international outlook and membership, was indeed deployed for 1 week last week in the area. Here you can see the different itinerary that they were followed in the 5 days that they were on site, the number of buildings that they were able to survey, and for which they could collect data that they will try to interpret in order to understand better the depths and dimensions, the very many different dimensions of this really incredible disaster. Just very quick, some very quick notes and pictures of schools and how they fared in Turkey, considering that our disaster, our chair is particularly related to the performance of schools in earthquake. And as you can see here, we have some masonry structures that had partial collapse, while, however, there's more let's say, better designed schools, and although they had some damage and some failure of internal partitions, they actually managed to resist. And the new schools that have been built in reinforced concrete, and these are schools that are 5 to 10 years old, have actually performed relatively well, and so well that are now used for shelter and as hub distributions for relief goods. The problem in all of this is that the education has been completely interrupted since the 6th of February, and so children are losing their time in school for the past 2 months now. All of this and more you will be able to hear on the 27th of March, so Monday next week, from 5:30 to 7 on the link that is shown here, where you can also have, which you can book up, sorry, and they keep jumping for some reason. We hope to see you there as well. And with this, I think we can close my presentation, and I will pass the mics to Abdelghani, who will start the SELENA webinar. Thank you, Abdelghani. You should be able to share now.
Thank you, Dina. Thank you for the introduction and also for this invitation. Let me see if everyone can see the full screen of my presentation.
Yes, we can now.
Right, just to put it, okay. All right, yeah. Yes, so this presentation is to provide some insight on SELENA, the seismic loss tools that has been developed. I think the development started first of time in 2004. It was a collaboration between Alicante and NORSAR. So the presentation will have two parts. The first part is to provide introduction to SELENA, what is exactly SELENA is doing, and what are the process, the computation process that SELENA is doing, what is the theoretical background on every computation that you can get from that can be done by SELENA, what type of outputs you can get. And I have selected just a few examples on application that we have done a few years ago. SELENA, it stands for Seismic Loss Estimation using a Logic Tree approach. So it's a seismic risk. As I said, that was developed starting, the development started in 2004. There was a consortium which called an International Center for Geohazard, and under this umbrella of this consortium, NORSAR collaborated closely with the University of Alicante through Sergio, and from NORSAR was my colleague who is retired now, Conrad Lidholm. So they started working on SELENA in 2004. But since then, there has been a lot of versions. SELENA has been undergoing a lot of development. We always kept it updated, introduce a new state-of-the-art procedure. So far, what you have is version 6.6. There is a version 7, which more or less completed before Corona, but because of Corona, we couldn't finalize it. I don't know why, but it's coming, the new version 7. It's a more interesting version, actually. There are a lot of things that has been integrated, which I will also show here. The core of the SELENA methodology is coming actually from the HAZUS and FEMA that was developed by FEMA. And of course, we have now included methodology from Eurocode 8 and other guidelines, worldwide known guidelines. What makes it special with SELENA, it's that it's very flexible, adaptive, and flexible. It is open. There is no restriction with respect to what form of input you can use and how you can use it. And also, it is not restricted in terms of implementation. Where do you want to implement the tools? So it's open access. You can modify inside, and you can input or provide your input wherever in any format that you want. And the other things that characterize SELENA, it's independent of any commercial software. So you don't need to have any commercial software. So you can run SELENA and do all the analysis, and you have huge flexibility in terms of where do you want to plot the results. For example, there are free GIS platform software like QGIS, and I guess I think my friend Sergio will show how you can get it, because they are ASCII files as input and also ASCII files as outputs, so very flexible. Yes, I already mentioned that it's an open source code, so it's very transparent. You can know everything, what is how it is doing, and also you can actually, if you know how you can if you are familiar with MATLAB, you can very easily integrate your own methodology. If you have something that you want to integrate, you can very easily integrate it. Or you want to modify some of the factor, for instance, a table that we are using with respect to amplification factor. I think now there is a new tables, so you can really work on this. You can really update it. I think these three are specific that SELENA has helped a lot in spreading the use of the software. So we think that software has a very good number of application and users. This graph, it's our rough estimate where the software has been used based on those who contacted us asking question and that they want to implement it and things like that. But probably there are more who use the software. So, yeah. So the main idea behind the development of SELENA is actually to provide organizations that are in charge of disaster risk management or response, or also for vulnerability or risk reduction planning with the tools and easy to use tools in order to estimate what will be a potential physical damage or losses, economic loss or socioeconomic loss for short or long term. So this was the main idea of developing the tools. On top of that, of course, making it easy, accessible, and also can be updated by users. This is where it comes from. Now, when it comes to the loss computation sequences, what the tools is doing is first generating ground motion and its parameters, and with here you have different options when it comes to generate ground motion. So either it is simulated by the user. So, and here we are talking about earthquake scenario that you can run. You define magnitude, location. You want to repeat an earthquake that has passed. For instance, the earthquake in Turkey, if you have a database exposure and you want to simulate it, so you can do it with SELENA if you have the data. Or predefined shake map. It can be uniform hazard map. Or this is something that you have done separately somewhere else. You have generated your shaking map. You can still use this map, integrate it, and SELENA can read it. And then based on your map, you can generate the damage and losses. And also there is another third option, which is near real-time analysis. And this is something that was done in Bucharest, collaboration project with partners in Bucharest, where they have implemented a system for near real-time assessment or analysis using SELENA. So this is for the ground motion. The other part is then when you have generated ground motion, then SELENA provides you information about physical damage in terms of damage loss ratio and things like that for a given building by type and also by GUnits. And then of course this will depend on how you have distributed your number of the buildings for a given building stock and so on. And the other points that you get or other information is the economy loss. And of course, this also will depend on how do you want to configure the economy loss model, which I will show later. So it can be direct economy loss or indirect. Indirect, for instance, business interruption, something like that, if you have data. And then the other points is the impact on population, human casualties, for different injury types. Of course, there is a huge uncertainty associated with this, but this is something also you can get. And amount of debris, this is important information for recovery. So that the debris resulted from the damage to buildings. And also for a number of inhabited buildings and or displaced household, shelters needs. So this is also for disaster management. It's very important and very useful information actually when it comes to disaster management. So mostly SELENA covered the whole phases of a disaster in terms of pre, after, during, and after disaster. So this is a simple presentation of the sequences, how it works. As I mentioned earlier, so you have the before that, I think this one, what I want first to show. So you have to generate or to define the ground shaking. So either an earthquake scenario predefined or near real time. And then from there, you obtain the ground shaking, and then the ground shaking combined with other input data related to exposure and vulnerability, you obtain the damage. And the damage combined with other input data like demography for the population distribution and the economy model that you want to obtain, then you get information about the economy loss, as well as the impact on your population, human loss, shelters estimation, and debris. So the color here, the gray, it shows you what are the input data, and the other shows the output. But this is quite a very simplified presentation. And if we look at the general definition of risk, so it is a combination of hazard, exposure, vulnerability. So you can very easily see what part of this sequence that represent a hazard, what's the part that represent exposure, and what part represent as vulnerability, and then the risk as a result. And here is the details of how it is done. So as I said, so here we call it probabilistic. Let me maybe, yeah, another. But it is actually, it's a scenario. So you have a single scenario that you want to repeat. Sorry, here deterministic. This is a single scenario that you want to repeat, or you have user defined map. So this map could be, yes, based on probabilistic analysis as well as deterministic analysis. This is map that you have done somewhere else, and then you are just bringing it as an input. Or this is near real time. So based on this, you have different way of how the loss computation will be doing. And we can also see where the input, what type of the input data you will get or you will need in order to run the different level of computations. And I think Sergio will later explain, or tomorrow will explain you this part of loss computation sequences, how it works and how you can prepare the data. Here, when you start with SELENA, you have a number of selectable options that user can do, and you have options for this, which are incorporated. But also you can, as I said, you can always add more if you wish. So if you have something that you want to include, so you can add it or you can modify it. The most important selectable user selectable options are related to first the provision of seismic demand. How do you want to define your seismic demand? Because from there you are using it later for the next, which is the consideration of seismic ground motion characteristics. So this is the second selectable. With respect to how do you want to, for instance, to consider topography or amplification, and how this can be combined. And the third important selectable options is what type of damage and loss you want to obtain, because this will depend, of course, if you are interested to only obtain the damage by buildings or the damage by area. And then when it's damaged by area, you can also get debris and other information. We can go maybe one by one for this important selectable, user selectable. So Here we start with the seismic demand, how you can configure it, or provision of seismic demand. You have the earthquake scenario. What is the earthquake scenario? Is, as I said, it's a user-defined earthquake scenario. Either you want to repeat a past scenario, or you want to implement or use a potential scenario that may happen in future, and you want to see what could happen, what could be the impact on the building stock, the exposure, as well as the socio-economic impact. In this case, you need to provide information related to the earthquake that you want to consider, mostly on location, the magnitude of the earthquake, the depth of earthquake, the focal mechanism, as well as selecting ground GMP, the ground motion prediction equations, which we'll show later. So these are the parameters that you have to define. Or if you have already done your analysis, for instance, let's say, for instance, you have used Crisis, or you have used it in other tools where it allows you to generate a shake map at bedrock condition or amplified. So then you can provide this information as AXI file. There is already in the guideline of SELENA, it shows you how you can prepare this file in the required format, and then you put, so it becomes as an input, and from there it will compute wherever you want to compute in terms of the loss, damage and loss. The third part is which is this one, is it's near real-time shake map, where you have to, of course, connect your SELENA to an existing network, ground shaking network, that can provide SELENA with the information in terms of PGA. So then it is generating ground shaking PGA and amplifying the PGA if it's needed. So these are the main three options that you can use in SELENA. With respect to the first one, the earthquake scenario, there is already quite a huge built-in GMP database that are inside that you can select. I think the last time we updated this, it was 2 years ago or 3 years ago, we updated the list of GMPs. So there is a huge amount of GMPs models that you can select, or you can even add new GMPs if you want. In the appendix of SELENA, you will see those GMPs, and also how you can integrate them for your computation. The second user selectable, as I mentioned earlier, so it's site-specific compute is a consideration of seismic ground motion characteristics. It's to how you characterize your ground motion, and then you are generating the ground motion distribution map at the ground surface. To do that, we have integrated various seismic code provision, which are inside SELENA, like IBC, the Euro code 8 for type 1 and type 2, the Indian code, it is there, and also the Cuba code. Probably we will add more in future, but there is also an option for the site specific if you are not using any of the shape that is provided by the codes. So this is quite it's very interesting as an option that we provide for the user. But of course you can add more your own code at the regional level. So if it's not selected here, then you can use add one of the code here in the table. On top of the various seismic code provision that are implemented, there is also features with respect to site effect, to consider site effect. And here I'm talking about first the soil amplification, near surface site condition, and this is something that that has been always an important factor to be considered when it comes to generating shake maps, especially if you have a region where they have quite a soft soil. So this is something it is important to consider to have an accurate estimation with respect to ground shaking distribution. And inside of SELENA, there are a number of those factors for soil amplification that you can consider. Here I'm just showing one of the example from the ABC 2006. So this is what you can see in SELENA. I know there is now a new table they updated, but it's not that big difference with respect to the numbers. So this is a table that, for instance, you can use it depending whether we are talking about short or long period, as well as what class of soil that we are talking about. It helps you to get a better estimation with respect to ground shaking. And the second feature relates to the site effect is topography amplification, surface geometry. So this is also something that we have. I would say this is it's one of the most recent integration in SELENA to consider soil topography amplification. We are aware that there are quite a number of tools for risk assessment, but not of them really takes into account the topography amplification. So a few of them only, even in the code, there is no much information about it. So we have addressed a few building code when we integrate in SELENA. So we have now two type of user selectable that has been incorporated in SELENA. One is the simplified provision from the Italian and the Eurocode 8 that we have integrated in order to account for topography. And the other one is the customized period dependent relationship. So this will be basically linked to the period of the system that we are talking about in order to estimate the amplification, the topography related amplification. Now we jump to the computation of the damage of loss. So we have finished with the estimation of the ground shaking distribution, how it is done in SELENA. Now we go to the second part, is how the damage and loss is computed within SELENA. So we mentioned that SELENA does a computation of physical damage, means the damage to buildings, socio-economic impact. This means that you need to provide these three types of vulnerability models inside SELENA. But nothing is mandatory. If you only provide, for example, only for the buildings, then the SELENA will only do the result for the building, and you will not do the result for the economy or the social impact. So this is so we have the fragility curves for the buildings, which express the physical damage to ground motion correlation. And then we have the economy vulnerability, and this expresses the physical damage to economy loss correlation, and the social, which is a correlation now with the social loss. If we start with the fragility that allow us to estimate the physical vulnerability or the impact. So now in SELENA, which is in version 7, it's not available in version 6.6. It can accept all type of physical parameters in terms of for the intensity measure. I'm talking mostly about the peak ground acceleration, the PGA, and spectral acceleration and spectral displacement. Until the version 6.6, SELENA only accepted the spectral displacement based fragility curve for the calculation of the damage. And this comes mainly from the HAZUS, the FEMA procedure. But then later, as I said, SELENA is always, we are trying always to update it. We have integrated the procedure that allows to compute the loss, the damage and loss if you have a fragility in terms of with intensity measure as PGA or spectral acceleration. And this slide summarizes all the procedure that are selectable by user. Means in the beginning, you select actually which method you want to use for the calculation of damage ratio. So if the first ones mostly are available, the capacity spectrum method, which has received quite a lot of success. It has been widely used, which is a convolution or intersection between the capacity curve resulted from the pushover analysis, the nonlinear static analysis, with the selected response spectrum. So we have the capacity spectrum method, which is from FEMA 440, and then the displacement coefficient method, including the improved displacement coefficient method. So they are two there. And three, these two are the method are they accept spectral displacement-based fragility curve. What we have added in addition to this method recently in version 7 of SELENA is the N2 method that is coming from the Eurocode 8. And Eurocode 8, mostly it's coming from the paper from 5R and Dolchek, where they have developed two procedures for the calculation of the performance. One is if you are using bilinear capacity, and the second if you are using multilinear capacity. Multilinear capacity, this is more when if you're building, let's say it has an infill, for example, reinforced concrete with in reinforced masonry infill. So they use multilinear capacity. Why bilinear is more if you have like a frame without infill, or you have something that doesn't show a dramatic change in stiffness when you are pushing or when you are doing the pushover analysis. So all these three are using, they require spectral displacement based fragility curve. Now, the other new that we have added is the SA based capacity curve, means spectral capacity curve with spectral acceleration as intensity measure. So you only need to define for a given building typology the period, fundamental period of your structures, as well as for the PGA. If you have the fragility now in terms of PGA, you can use it in SELENA. So from beginning, you have to define your model, the vulnerability model. Are they SD based, SA based, or PGA based? And then basically from there, this SELENA is computing the damage loss, or damage probability for every single typology, and for a given GeoUnit and for a given typology. On top of that, it calculates the mean damage ratio that represent either typology or represent a given GeoUnit that characterize GeoUnits that you have defined for your area of study. I think I have to run a little bit. Now there are a number of challenges when you are doing SELENA, or not only SELENA, when you are doing risk assessment for a city or region. There are a number of challenges. This is coming from our experience because we did this work in many places, and we always get this type of challenges. One is related to the collection and handling of inventory data. The second is the scale and resolution of risk study, I mean the area that you want to study. The third challenge is if you don't have your customized vulnerability model or fragility model, how you are going to, what process you will follow in order to select those that exist providing literature. And then we are talking about how we are accounting for uncertainty in SELENA. So the collect and handling of inventory data, it's mostly related to the building stock and also economy loss model, how we do that. So it is a bit challenge to define, to develop what we call building typology model for a given city. So we have really to look closely to what typology exists and what structural system exists, and also level code design or period of construction, because this helps us to understand the age of the building and also how well is in terms of performance for the buildings. But also there is another parameters that we look at, is the state of preservation, because some buildings which are recently or newly constructed, but there is no maintenance of the buildings. And then with the time they start losing their initial characteristics. So there are a number of these parameters that we look at to characterize the building. Sometimes it's easy, but sometimes it's not easy, because we are talking about doing a risk assessment of a city, and it's not always easy to go inside. We are not going inside on every single building and look at the characteristics. We have to mostly do the work from visual, from observation from outside, and then we have to select just a sample of the buildings and then interpolate this to the city. Of course, this then will enter a number of the a number of uncertainties inside. There are some kind of guidelines that provide definition on how you classify your structural systems, or how you classify your buildings into different typologies. The most well known as the HAZUS one, and also there is also in EMS the European one. The advantage of this, they provide also a database of fragility models. But of course, you cannot just, there is a rule how you can use those fragility in order to get a real and accurate results. You can also find a lot of in the literature how they define and classify the buildings within a stock, and then how they can develop their model, their exposure model. For the economy model, it is also in SELENA, you have also options whether you want to enter the economy loss model as a single buildings or by meter square, and then you need to prepare this kind of information, which is also quite challenging, and a lot of assumption and simplification has to be entered in order to be able to construct this kind of model. The other question that will come later when you are developing this model is what value we are entering here. If we are talking only about direct loss, then it may be only the value of the buildings and the content maybe. But then if you want to include the business interruptions, if you have commercial or industrial buildings, this is also something that it can also a challenge to make an estimate with respect to the economy loss model. The other one is, as I said, in the list, the scale and the resolution for the area. So the more your region or the size or the resolution of the grid are small, the best will be. I mean, the best will be your results, because then you are here. You are decreasing the uncertainties and decreasing the uncertainty. But then, of course, it might be an issue with respect to the level of details. So it will be very, very difficult to make small grid if you have larger area. Sometimes we are forced to increase the grid because otherwise you need to provide a lot of details, which is time consuming. So here it's a balance that you have to do between the uncertainty in the loss result as well and the required details that you need to enter. And of course, all this comes based on how size What is the size of your city? What is the number of population, as well as how dense is your city? But the other factor we look at it in order to define the grids are the condition of the surface. I mean here, for example, this is an example in Guwahati where we were looking, because Guwahati, they have a lot of hilly top area. And when we talk about hilly top area, definitely there is a change. It will be quite a huge change in terms of ground dimension distribution. So in hilly top or surface area, flat area, it's different. So we were looking, trying to identify where we do have hilly top area, and then when we define our GeoUnit, we take this into account. The other things that we have to take into account is the site condition or the soil classification, where we have rock, whether it's rock or hard soil or medium soil. So based on this, then we classify, because we assume that as an assumption, a GeoUnit, we have to insert an average value for the ground shaken. And then in this condition, we have to avoid to have changes in or dramatic change in site condition or in soil condition in a given GeoUnit. Otherwise, then you get a bit weird results. Now, with respect to existing vulnerability or fragility model, as I said, there are a lot of models that are available available in literature, and they depend. Those models, are they developed for individual buildings or city or a county? So, whether they are developed for a single building or they are developed for a group of building. Because if, for example, you are doing assessment for a city, and then you find a fragility curves from literature that was developed for a single building, you cannot use it, because then you are entering a lot of uncertainty on it. It has to be a fragility that was developed for a group of the building, and that the typology is close to the typology you are looking for. So here it's more about combining the user application scope and how the fragility were developed, individual building or facility, a city or county. So the size for which those model are applicable. But this doesn't mean that that can be applicable, even if it covers the scope of your application. For instance, we know that hazardous models or hazardous fragility curves are developed in order to do this risk assessment for a large city or for city, not for individual building. But it might be the buildings in US that have completely different characteristics in terms of design, performance, and other characteristics that are different from your region of interest. And here, as an example, I'm showing what I have found when I was using customized fragility model for Santiago de Cuba in Cuba, and using the hazardous model. So you can see that this is leading completely different results, and the influence of vulnerability model is quite significant. So you have to be very careful when you select your fragility models, that your database of fragility models that you want to use for your study. This will have impact not only in terms of damage, but also in terms of economy loss, for instance, here. So you see that how different are the results between using two different models. I think this is the last slides, and then I am exactly at 3:55, as mentioned in the agenda. That there are uncertainties. Always there will be uncertainties. Mostly we are talking about epistemic uncertainties when we are doing loss assessment. Nothing is perfect. The uncertainty can come at the level of defining, for instance, if you are doing loss assessment, if you are doing earthquake scenarios, then there is uncertainty for a given earthquakes that the magnitude is not the magnitude that you want, or the location or the depth. So with respect to GMPE, because most of the GMPE or most of region, they don't have their customized GMPEs. So what they do, they select GMPEs that exist, like the ones that are provided by SELENA. So here you may have different options of GMPE that you feel that all this can be used for your case. Or even the soil model, if you don't have enough information with respect to soil model, the VS30, and then you may be hesitating which one you want to use, or the fragility model. So all this we are within SELENA is taken into account by applying the logic tree scheme, where you can weight in and use more than one model for at different different steps, and use one model, and then you define which weighting you want to use for this. As a result, SELENA will provide you results in terms of median with 16% and 84% fractals. This is a very useful information, and it helps actually to better see or to have a better overview of what you should expect as a result, and also the expected value and the confidence level. And I think with this, I finish my first part for the presentation about SELENA, and then next will be the SELENA application after the break.
Thank you very much, Abdelghani. I don't know if there are some questions at this particular point, if there is anything in the chat, or anybody wants to open their mic and ask any burning questions before the break. Yes, Bahid Shafai, please open your mic. In fact, even open your camera if you want.
Hello.
Yes.
Thank you for your presentation. I want just to ask the last slides about the scenario weight, because I just see that, for example, point 2, there is equal weight for all scenario, and you write down about a normalized weight. I want just to know about the case that we select a scenario in an equal weight or something like that.
Actually, this was just put in numbers. That's it. Yeah, you may. It's up to you. Actually, depend on how confident you are on the selected models. Sometimes you feel this models is better than the others, and then I will give a weighting of 0.6, and then I will give weighting of maybe 0 for the rest, or the other will give 0.3 or 0.4. So first, there is no limitation with respect to how many models you can select, and there is no rule what weighting you should assign to each of those models. There is no rule. So it's all depend on your level of confidence with the selected models. The total must be, of course, 1. So
okay, just the
yes,
total
the decision on the weights is rather arbitrary in the sense that it will depend on the end user.
Yeah.
Does that answer?
And of course, yeah, if you choose to select only one, then you assign a weighting of 1, and the rest, then here you get, you are confident that this is the model that you want. Yeah, I think there are more questions, Nicolas Ortega.
There is also, yes, Nicolas, do you want to?
Hello, did you listen to me?
Hi, Nicolas.
Yes.
If you can say also where you are speaking from.
I'm from Colombia. First of all, it's a very interesting meeting I think we can use this tool in my country for evaluate a lot of scenarios in risk. So I have a question. You can apply SELENA in a city that they don't have any information or any recent data?
Information?
Okay, I don't know, I think we can apply SELENA in many cities, but maybe these cities doesn't have a lot of information about these earthquakes information or this data like that.
Yes, this is what I was mentioning. I mean, it is always challenged to collect the data, and it's very clear the level, the quality of output depends on the quality of the input. The more the quality of input is better, then definitely the quality of your output will be better. So SELENA can be applied. You can, in worst case, you do some assumptions. For example, as I said, sometimes we cannot do the inventory for all the buildings, so we just select a sample of building and then we do interpolation. This is an assumption that reduce the quality of the exposure for the building stock. It reduce it, but this is an option that I had to go for it because otherwise I cannot finish. It's not that easy to do risk assessment for cities. So you need a big budget, many people. So thank you.
And thank you very much, Nicholas. We have hand raised by Professor Daya Shankar.
Yeah.
Yes, would you like to introduce yourself and tell us where you are?
Yes,
I recognize the building.
Yes, I am from the IIT Roorkee, professor here.
Okay.
Department
Nice
of
to see you.
Engineering. Thank you. Very nice presentation. I have not a question, but just a query. How in the SELENA you have incorporated the basin and this topographic site effect? What type of data needed to incorporate in SELENA?
Actually, it's more data related to the shape of the surface based on simplified options, mostly coming from the Eurocode 8. And of course, there is another options. So it's not that huge. It's still a very simplified procedure. And the only data you have is more on the height and the angle of your feature. So the topography feature. But I think later with Sergio will show the tables, how to prepare this data and what type of the information.
Okay, thank you. Thank you. Very nice.
Good. Any other question at this point? Then if there are no other questions, we will have about 5 minutes of break and we will resume.
Excuse me, I can ask a question?
Yes, please. If you want to introduce yourself quickly.
Yeah, I am Dr. Dheeras from one of the institute in India, Engineering Institute. I am professor here in Department of Civil Engineering, MNIT Jaipur, teaching Rajasthan. So my question is from Abdul. Perhaps Abdul know me.
Yes, I remember you.
Thank you.
That's good.
Yeah. So my question is that can we extend this method to other structures also? Like
Yes.
It is essentially for building. Right now we are facing the like transportation network and other distribution system. Can we extend this method, or is there any trick if you want to share, please?
Yeah, actually, yes. For now, SELENA is using GeoUnit, and infrastructures. It's not one single. It's not a GeoUnit. It's single points, right? I used recently SELENA to do an electric power station. So what I have assumed every single position of power stations is a geo unit. You can, of course, use it, Selena. Yeah, you can use
So
it.
somehow in some more or less you can say that I'm using SELENA right now currently for assessing the seismic risk of 60 smart cities in India. Already
Yeah.
I'm using this method.
Okay.
So currently we are working on that project.
Yeah.
So yeah, thank you.
But I think, yeah, definitely we are looking to improve it in order to allow to integrate infrastructure or critical buildings, like for example, hospital, schools,
Yes.
they are critical buildings. We need, when we assess them, it has to be one by one, not as a G units. So this is because they are important in case of emergency. Yeah.
Yeah, thank you.
Yes, I think possibly Sergio will also show tomorrow an example of where instead of using the geo unit, we use a building by building approach. If there is time, we will see.
All right.
Yes. Okay, great. So why don't we break for 5 minutes, have a drink, get to stretch your legs, and we will be back here very soon. Thank you, everybody.
Thanks.
Thanks.
Hello, everybody. If Abdelghani is back. Yes.
Yeah.
Thank you. You have your coffee, tea ready for the next implement, the next installment of SELENA. Thanks. And as if you want to just put your comments in the chat, then we will take it up at the end of this session.
Yeah, here I have just two applications, but one of them is a really full application. It's related to Guwahati, a city where we have been working there. I'm personally have been working there for almost nine years with the Jayanta from Assam Engineering College. We did a lot of work there. So we had 5 years project, but then we started another 3 years project together. And all the project, it was about hazard and risk assessment in Northeast India, focusing mainly on Guwahati city. So Guwahati city is located in the highest seismic zone of India, as you can see in this map. So Northeast India is one of the highest is zone with the highest hazard when it comes to earthquakes. On top of that, they do have other hazard like a flood, which is also not, it's very significant in terms of impact, economy impact, as well as the social impact. So we did quite a very thorough hazard assessment investigation, where we have identified the most potential scenario by looking at the past scenario, the past earthquakes that were in the region. And one of the most famous one is the Ceylon earthquakes of 1897. So it's a very famous earthquakes, and this is the one was one of the scenario we considered for the seismic hazard. So what we did is we did the investigation, trying to develop the building classification scheme for Guwahati by doing a field survey, and also develop the inventory database based on the random sample survey, as I explained earlier. And then we do this interpolation once the typology is defined. So we identify the typology, and then when we do the survey, we assign the typology to the buildings, and each means buildings in each G unit. So the city is divided into a number of G units, and then on top of that, we have developed the economy loss model that will be used. Economy loss model is we estimate what would be the loss in terms of meter square by meter square, the cost by meter square for a different level of buildings, the value as well as the before the earthquake as well as after the earthquake for different damage states. So this is some of the pictures where we were doing the field survey, looking at the building from outside, how they are designed and what are the factors that may affect the seismic performance. For example, like seismic funding, the quality of constructions, and mostly of the things that we have observed, there will be a lot of open ground, which makes the ground floor very, very soft comparing to the rest of the floors on top. So and this ground floor are usually used as commercial for the commercial activities, and or as a car parking. So here in this picture, I don't know if you see, this is my former colleague Dominic. He's here. When I was taking picture, I took his picture here, so you can see him here. So once we looked at the building, then we classify them into three categories. So engineered structure class that has been based on modern code. We estimate they are good quality. They are mostly newly constructed buildings. They follow the newest code, and also they are in a good shape. State of preservation is good. And we have also engineered structure, but they are either pre or low code. And typically we call them, this is the most typical quality that we observe. And mostly they represent residential and commercial buildings, especially mostly residential, of course. And then we have non-engineered structures, which are informal construction class. Mostly used for they are used for residential purpose, and they are always in quite a very poor quality. So we looked at those buildings, we identify the most important parameters, we look at it, and then we come up with a classification, which we call model building typology scheme for Guwahati. So we classify the city, look, as I said, in terms of material class of the buildings, what material type, system type, load bearing, what is the system for the load bearing, the material of the load bearing. We looked at the roof system and material, and the system material floor, and then of course the height class, but also the quality of construction. And quality of construction, sometimes it's the one that really define what will be the seismic performance of the building. And then we have come up with the code that we assign for each of this typology of the building. So then we apply this MBT or model building typology to the building stock in each unit. And then here, this is just a simple presentation in terms of concrete, ductile, concrete, non-ductile, masonry, timber. And this is another presentation in terms of occupancy type, whether it's residential, commercial, for education, health, religion purpose, or yeah. There are more information that we managed to collect relates to the building height class, whether it's high rise, mid rise, low rise. And then of course the population distribution, because then this will be needed in order to estimate the casualties for the different scenarios. So all this information are about the building, people who lives there, and all the activity. But then we also worked on collecting the information about site condition through the collection of shear velocity. There has been a lot of work and a lot of projects which were, most of them were funded by ASDAMA. It's the Assam State Disaster Management Authority. They funded a lot of projects, and those projects, most of them were aiming at collecting information about site condition. So we did collect all of this information, and we created this nice map that shows the distribution of shear velocity across the city. But still, this map, it still needs more improvement, because Guwahati is well known to be prone to liquefaction. And in many regions where there is liquefaction, there was no available VS30 information or profile or that help us to identify the quality of the soil. So this site condition, in combination with what we have selected as scenario, the reason why we select them is one is because this is an earthquake that happened in the past. Two is because they may have impact on Guwahati. Some of them are far away from Guwahati, but the fact that they happen with high magnitude and at almost at the surface, it's only 10 kilometers. So even the distance sometimes can be 80 kilometers, then it might have actually impact on Guwahati city, especially that if we look at the Guwahati again, many places in the city, they have velocity, it's between 200. So this is not really good soil. So it's going to be like soft soil, very loose soil. And this is just information about the selected scenario that we have applied to the city, where we identify the location, focal depth, magnitude, fault orientation, deep angle, mechanism. So these are the information that it's required to be provided by SELENA. So in SELENA, you need to provide information like this in order to be able to run the earthquake scenario. So you need to have all this information. And for us, we got this information based on our literature investigation for the different earthquake scenario. So combining those scenarios with the selected GMPs, so we selected a number of GMPs, applying weighting for the GMPs with the site condition through VS30. So we manage, for instance, this is just one example that shows the generated ground shaken. This is the ground shaken generated for the scenario Oldham fault earthquake scenario. The magnitude 8 and the focal depth was 10 kilometers, and it's approximately 80 kilometers distance to Guwahati city. And the fact that it has really a very bad site condition in many places, so we can expect actually values of PGA bigger than 0.50 G in some places, right, where there is also risk of liquefaction. And especially here it's a very dense region. So it represents the old city of Guwahati, because Guwahati was only this part, and then it started growing fast and going in all directions. So I selected only one scenario to show for you, and in order to show you what actually you can do with SELENA. So in SELENA, the first things what you can do is, of course, you can get more than not only this information, but you will get information about a full spectrum at each G unit. Means that you will get spectrum for different periods, and you will get it for different also. Yes, you will get it at 0.3 second, at 1 second, yeah. And then what you can also get is the damage building. Estimated damage building is a percentage by G unit. So here it shows what we have estimated as a damage. The information for the damage, you can also get it in terms of mean damage ratio. So it shows you more or less which G unit mostly affected, but actually it's not. You cannot take it as the most affected area. Why? Because in each and this is one of the shortcoming or limitation or that we have when it comes to G unit. Because for instance, in the G unit, which is red, there is only few buildings comparing the G units that is here. So when you see red, it's not really red that, oh, here it's the most affected. There are only very few buildings comparing to others. And I think I have shown it in the previous slides here, where it shows, was it, yeah, probably not here, but I had it somewhere. Right, so this is in terms of mean damage ratio. Then also you have the mean damage ratio and you have the number of the building. Then it's just a matter of convolution. So you can then obtain the direct economy loss here. And we can see that most of G unit will be affected because the damage will be affecting all the city, as I showed in the first figure showing the damage distribution of the building. So on top of the economy loss, you can get the amount of debris. This is information, important information for recovery purpose. So you can get the amount of debris. Also, for the emergency response, you get the number of homeless And basically this reflects the number of people that need to be evacuated to emergency shelter. And then you can also get the impact on people as expected casualties. We have, and we can do it in SELENA for different time windows, in rush time and non-rush time. So here we selected at 2 a.m. 2 a.m. means that most of the people are at home at 2 a.m. So what would be the impact if an earthquake happens at 2 a.m.? And then at 10 a.m., many people are at work or at schools. So most of the residential buildings are not really full. So people are outside. And then at 5 p.m. also this is at 10 a.m. and this is at 5 p.m., which is rush time. Also now people are going back home, but they are not sleeping. So this makes a difference between 5 p.m. and 2 a.m. 2 a.m. people are sleeping, but 5 a.m. people are not sleeping. They are at home, but they are not sleeping. So, and this makes a huge difference, right? So this is assumptions. This result are based on assumptions that are inside SELENA, which is come mostly from recommendation from HAZOS. But of course, from country to country, this is change a lot. So it needs to be customized by the user. So this is something that user is required, can of course change it in SELENA and change population percentage indoor and outdoor for the different time windows. So this is something that you can do yourself, right? And then the other things that I want to mention is my presentation here is showing expected casualties. We are not showing what level of casualties, because in SELENA actually you can do this if you want. Anyway, the result will be showed for different level of severity. And this is definition coming from FEMA 2003, where they define 4 levels of severity. Severity 1, which is injuries requiring basic medical and aid, and which can be treated at the site. And then you have severity 2 and 3 and 4. But we know that this is quite it's associated with huge uncertainties. But it is there in SELENA, and it can always also be quantified or changed by the user. So this was for Guwahati, India. The second case study that I want to mention is Santiago de Cuba. This is work that we did in 2015. Santiago de Cuba is, you can see where is located quite. It's a very low part of Cuba. It's here, and historically the city was hit by earthquakes. There is no much information about the damage really, but we could only collect very few old images that describe the earthquakes that hit the city. And this was a collaboration with partners from Santiago de Cuba, where they helped us to define and develop very nice. Actually, we managed to develop a quite nice exposure model for the city. It is one of the most dense city, especially in the center, where it represents the old town of the city. And you can see the zoom here of the city. So it is very, very dense city. So we have managed to develop building typology class for the city by looking at the different characteristics of the buildings that are in the city. It was not easy to do the classification, because there is quite a huge variation in typology in the buildings. And many of the buildings that exist are residential. They are quite old buildings. Very few are new constructions. They use most of the material used for the constructions is concrete. Very few use of steel buildings. Only very few buildings that we could observe are made of steel. And we basically constructed our exposure model in terms of number of buildings and population. And of course, based on the hazard study that was conducted, we selected 4 earthquake scenario. One of them is even inside the cities, is within the zone that we selected. But it was small, that one. So the big one was the one outside of the city. And we have managed also to create this VS30 data that covers the city in order to be able to generate the ground shaking, taking into account site condition. And from there, so we basically repeated the same process that we did for the Guwahati. Here I'm just showing the estimated building damage and the economy loss as a result. Yeah. One thing that maybe you haven't observed is most of the study that we did so far, we did not include the topography, because this is something it was just recently implemented. But the other things that we are also interested to include is taking into account a ground motion correlation. This is something that we will see in future how it will be possible to include it, and maybe also to improve the information in terms of uncertainty, how we can address this in the future. With this, I think I'll just say thank you. If you have a question.
Thank you very much, Abdelghani, for these 2 very clear examples, which show what type of results can be obtained with SELENA. Is there any question at this time? I think, yes. Professor Daya, if you want to ask.
Yeah, yes. This is also a very nice presentation, and you have given a vast review about this case study of this Guwahati city, Cuba, and Santiago. So I could not find whether you have incorporated the date and month of the year. Sometimes in the India, at a particular date and the particular month, people are celebrating many festivals, like in 26th January in Gujarat. The school children were just celebrating the Republic Day, so building collapsed, and there were maybe 400 and 300 people at once injured, and there was casualty. So maybe if not, so you can include the date and important month for the loss estimation and casualty estimation in our SELENA.
Yeah, of course, there is flexibility to do this. It's just a matter of configure the population indoor, outdoor, and then you say, okay, for this scenario, I have assumed that this will happen during a festival where you have a lot of people are outside, maybe. Yeah. And then since the buildings are dense, then it may create a huge panic. So you have a lot of people and the collapse. Yeah, you can do that. You can just do this. You can select this. And of course, the big question would be the estimation of people, how people will be distributed and things like that. Yeah.
But also clearly the probability of those two events occurring at the same time.
Yes. Yeah.
Yes. So that's the major issue with SELENA. That if you do a probabilistic assessment, then you need to think of what are the chances of that happening. I think before I go to the other raised hands, there is a question from Adriana Fatima Ornella Sagrella. She's asking about what do you mean with the mean damage ratio that you had shown in slides 48? And what is the difference between the mean damage ratio and the direct calculation that you show in slide 49?
Okay. We are calculating the damage for individual buildings, but then we are grouping for the buildings that are in G units. So in G units, there are buildings of same typology, but also there are buildings that from different typology. Every single building will have as a result damage ratio, which is resulted from the probability of damage. So when you sum up those damage ratios of these different buildings and you divide it with the total, you will get the mean damage ratio that represent a given G unit. And you can get different way of damage ratio, mean damage ratio. You can, in SELENA, you can obtain it for a typology. You can obtain it for G unit by typology in G unit, or you can obtain it in G unit, means that you combine all the typologies all together in a given G unit. So you have multiple choice actually that how do you want to do it?
Okay, thank you very much. I hope that this answers your question, Adriana. And we can go to Munir.
There is
if you want to unmute yourself and present yourself as well. No, now you're muted. Hi, Munir. You are muted at the moment. You need to unmute yourself.
Yeah,
yes.
Now it is working. Yeah. Thank you very much for the presentation, Ghani. I'm much more concerned with two things. The first one is regarding the scenario earthquake. So you've mentioned the magnitude, but I'm questioning myself, what kind of magnitude? Is it body wave? Is it moment magnitude? Is it record magnitude? This is one thing. The second thing, what are your ground motion attention relationship there? And for each scenario, what is the probability? If for Guwahati, you have mentioned that the magnitude is 8. So I'm questioning myself, what is the probability of having a magnitude of 8 at Guwahati? So this is just a quick question.
Yeah, okay. In SELENA, we don't do the difference in terms of the magnitude. And with respect to the probability, this is a deterministic scenario, a repeat of a previous earthquake, of an earthquake that happened in history. We are not doing like, if, for example, you are selecting uniform hazard map, then uniform hazard map is linked to a return period, right? And then the result that you get, in this case, you need, of course, a full hazard curve in order to say this is annual loss. Not deterministic loss.
Yeah.
But here we are talking about deterministic loss, means that there is no probability that.
Yeah, but I agree with you. I agree with you. I totally agree with you. Yeah, but what about the ground motion relationship, the attenuation one?
The ground motion, we selected Embraces because Embraces in database, they use the Middle East data and the region. So there was an issue of GMP because in India, they don't have customized GMPs that represent the tectonic condition of India. And this is a problem not only in India, in many other countries, they don't have really customized GMPs. And even the new GMPs that they mixed the region. So Embrace himself, he mixed the data. So when we then it's GMP. It's not for a specific region, but it's more. It's not specific location, but it's more regional. So we say this is a GMP that represents the Mediterranean condition or the Middle East condition. There are always uncertainty with respect to GMP, but this is not an issue. This is almost a universal problem, so it's everywhere. There are a lot of now GMPs that they call them like universal GMPs that you can apply them anywhere, everywhere. But yeah, of course, there will be, because it affects the shape of response spectrum that you get at the end.
Absolutely, absolutely. Thank you.
Thank you very much, Munir, for these very relevant questions. I think Azim had raised his hand earlier, but now it's not on. So I will go to Azim. If you have a question, please raise your hands again. Otherwise, Sohil Rana, please. If you want to unmute yourself and yes.
Thank you, Professor Dina Diayala. Thank you for arranging such a nice webinar continuously from the UNESCO Center. And thank you, Professor Abdul Ghani, for your nice presentation of your theoretical background and application of SELENA. I am from Bangladesh, and I am working related to earthquake hazard risks and probability. In probably, I am very much interested in multi-hazard risks. And I have known about SELENA, I think about 1 month ago. We are working on earthquake risk assessment of our buildings from our select city, I mean city scale buildings. And actually, as you have told during your presentation, that the data collection is a very tasked to collect the data here in developing countries. So as you have applied SELENA in various regions, and I think the fragility models you have used from HAJUS multi-hazard program. And from one question of another participants or audience, I have seen that we can also apply for this approach for industrial buildings or health facility buildings or other types of emergency facilities, and which can also produce the damage of the physical damage of the buildings or loss from the buildings. This is one question. And another question is you have introduced newly the surface geology. I think it can be amplification, site amplification that can be. So do we need site amplification in another program and incorporated it in your SELENA for every buildings, or just we have to include some parameters, soil parameters, and your program will provide site amplification factors for the geogrids? And another last question is, as data is very scarce here, and maybe we have faced in our Select City project here in Bangladesh that we cannot data the asset value of every buildings. We are doing works for around 49,000 buildings, and we cannot handle or collect the data for these buildings. So will your SELENA give other results independently, or it obviously requires these inputs, the asset value of the buildings, or other value will be provided without providing this, and we don't have these.
Okay, so I'll let Abdel Ghani answer you.
Yeah, I'm not sure I understood the first question, but second question about the amplification. Yeah, currently we have embedded tables where they define the parameters for amplification. Now, if you are doing an earthquake scenario, the only chance in order to enter your own amplification is like you have to modify in the script inside the SELENA. Elsewhere, if you have already generated your ground shaken, you just need to amplify it before you put it as an input data for SELENA. And then you get the loss, the damage and loss and things like that. maybe later or tomorrow, Sergio will talk about this with respect to the amplification. What was the second question about building, which
I think it was something about data resolution. There is
resolution?
also another question about the resolution with which you display the damage. So,
Well, as I said, the resolution is grid that you define for your maps, and to do that, it has to depend on site condition, because and also the level of details of your data that you have, okay, and the distribution of people of the buildings, because and the size of your city. So
yes.
as I show, so this is what affect actually the resolution. So if your city is small, then you need to reduce make it smaller, the grid. But if large, then you have to enlarge a little bit the grid, because otherwise it will require you to collect a lot of details. But you need to be very careful with site condition that you are.
And it depends on the data on the exposures that you have, your knowledge of the building block. Azim, yes, please give us your question.
Yes, thank you, Dr. Ghabghani, for your very nice presentation. I'm Hazem Badruddin, seismologist at Earthquake Department in Riyadh, Egypt. So part of my question you have answered for Dr. Munir. I wanted to ask about, you have shown us that there is a worst case scenario that you have used the deterministic approach to estimate the losses. Currently, I'm using BSHA to estimate the ground motion at the specific sites. So can we use these results from BSHA to estimate the risk as well? Which is for the input for people that using OpenQuake crisis, is it a risk? Can we adapt the input by?
There is a very simple format that you need to prepare. Once you have done you generated your shake map in crisis or any other tools, OpenQuake or wherever, you just prepare it as a very simple Excel file where you have latitude, longitude, and the full spectrum that you obtain. And then you inject it as an input file. So this is what we call user predefined hazard map. And then if, for example, you have already taken into account the amplification, then you simply, the VS30, you assign VS30 that represents rock, means that all the values will be multiplied by 1. So there will be no extra amplification considered.
Okay, thank you very much, Abdelghani. I think these are the questions, and we are very quickly heading towards the end of our session. So Sergio, without further ado, if you want to share your screen, and thank you everybody for the questions which have much enriched the presentation.
Thank you, Dina. Let me see if I can share my screen. This okay.
And Abdelghani, there is maybe a question for you in the chat that you
has Selena been previously utilized in country looking north of? I don't think so. I'm not aware whether it was used or not, because I'm not aware that there is a vulnerability model ready to be used. There are some studies mostly done for Algiers, which they have quite a very good exposure models. But it was not Selena. I think it was just one of rescue procedure, the rescue methods, simplified methods for the damage.
So maybe it's time to think about it.
Yeah.
Sergio, please. Thank you.
Thank you.
Thanks.
Thank you. Well, I'm going to just simply to introduce what we are going to do in the session of tomorrow, and it's just simply that you have enough time in order to download the software to prepare some data, and tomorrow we will employ the webinar just to work a little bit on Selena to understand the input files to see how we can prepare an ECS scenario. So as we have been seeing in the lecture of Abdelghani, what we are going to do tomorrow is mainly to work using a predefined computed shape map scenario. We will work with some exposure and vulnerability, and we will also work with the fragility functions in terms of spectral acceleration and PGA based fragility functions. So that means that what we are going to use tomorrow is the SELENA version 7. I mean, it is just still in beta version, but I have tested the most of the software, and I think that it's mainly running perfectly. So this is the link that it will be shared with all of you, so you can just try to download for tomorrow all the files that are in the folder in the link. So you will see that there is a folder called manual and installation, where is a PDF and a video. So the PDF is just simply the whole SELENA manual. That is a lot of pages, but you will have enough time in the future to read it carefully and understand all the meaning of the methodology and the input files. And the video is just a short video showing how to install the software. So just simply reviewing the manual, the information needed to carry out the seismic risk estimation using shape map analysis. This is the pre-computed shape maps. And check also the input file stored in this folder. Example, input files project specific. I mean, because what we will do is to show you how to use the examples as a template for preparing your own input files. And if you don't have MATLAB installed in your PC, just install the standalone version for Windows 11 64-bit. And once you have installed it, just simply try to run one of the examples, just simply writing SELENA P. That will, if everything working, that means that you have installed correctly the version. And one of the frequently answered questions that I always receive is that usually it's not working, and it's not working because you are executing SELENA outside of the folder in which the input files are. So take care about that. And anyhow, anyway, we will see more in detail tomorrow. So just that you start looking for information. The first thing that we will look for is the Philippines administrative boundary shape files, because we are going to download the regions of Philippines, and the regions of Philippines are going to be our geo units for the example. So this is completely free. You can go to this GitHub web page and download all the administrative boundaries. What's going up? Okay. The second thing that you have to do is to get data from OpenQuake. So in order to get data from OpenQuake, the first thing that you need is to sign in into the OpenQuake platform. And once you have signed in the platform, you will be able, for example, to look for exposure data. You simply write here in the search part, the country, Philippines, you say search, and then you will get the exposure. And see, for example, the exposure data for Philippines, and we simply download this data that we are going to use tomorrow. There is also a hazard model for the Philippines, but these are just only the input files for OpenQuake, so we are not going to use this. As Abdelghani has told, we will need a fragility model. So what we are going to use is just to use also a recently published global fragility model, which was published by Martin and Silva in 2020. And it's also free, and it's also in GitHub. So we also go here and download this folder fragility curves, and I'll show you tomorrow how we can convert these files into what is needed in SELENA. As we are going to use a pre-computed shape map scenario, we will need the hazard map for Philippines. So the best thing for doing that is going to the Philippines Volcanology and Seismology Institute, PVOLCS. And there is also a service in which you can download hazard maps. You search for at a national level, and you select the peak ground acceleration and the spectral acceleration. So we will work with the whole spectra in terms of probabilistic seismic hazard. So you also download this. And we also will need the site condition. So in order to do that, what we are going to do is to see how we can obtain data, global soil condition from the USGS webpage. So there is also a place in which we can browse and download data from the BS30. And when we have this map, we can select Philippines, and we can say, okay, I want to download the data from BS30 Mosaic. And BS30 Mosaic is because, you know, USGS is computing BS30 using this topographic slope model. But if in the country there is also BS30 measurements, which are done by other methodologies, they incorporate that measurements, and that's what they call the mosaic. So we will use this layer to get the soil conditions. So as a summary, what we should do for tomorrow. First, we have to download of course, to download SELENA, but download the administrative regions and plot it into QGIS, so we know more or less where we are going to work. We have to download the probabilistic seismic hazard assessment files, which are in KMZ format, and also plot it into QGIS. We have to download the exposure data for Philippines. And when you download the data, you will see that you have residential and other information. Yeah, we are only going to use the residential information. So just simply import it to Excel. And once you import to Excel this information, try to create some dynamic tables in Excel to obtain, for example, the number of buildings, column G for each taxonomy, which is in column F, an administrative region, which is in column D, another dynamic table with the build area, which is column H for each taxonomy, column F, an administrative region, which is column D, and also a dynamic table for the population, which is in column E for each taxonomy and administrative region. So because these are the main input files needed for SELENA: build area, number of buildings, and total population. Remember also to download the fragility curves from Martin and Silva. Once you have everything of this, just simply try to check all the input files which are inside this folder in SELENA. And think, don't try to create the input file, just simply think how you will be able to create your own input files for Philippines by using the data that you have downloaded. And tomorrow we will solve the questions, and we will see how I have created the input files, and we will see all the different possibilities. So I think that, yes, that is the introduction for the session of tomorrow. Yes, so most importantly, come back tomorrow at the same time. If there is any question now, several people have asked if we will share this presentation. So as soon as we close the webinar, there will be a Zoom recording, which we will upload on the website of the UNESCO Chair. I've sent earlier
link in the chat, but you will also, it's just sufficient to go to the UNESCO Chair website and the educational activities. Any question directed to Sergio about what he has just explained? It's all very clear. Then in that case, it's important that you download this material and you start playing with it tomorrow morning for us, or tomorrow later for you, for some of you, or this late evening, so that we can that you can do your own assessment, risk assessment tomorrow, hands-on, which is the whole purpose of the seminar. Thank you very much. Thanks, Sergio.
Thank you.
And we will see you at 2 p.m. UK time, and whatever time is in your part of the globe. And thank you for attending. Goodbye, everybody. I very much look forward to do it myself. So.
Yeah, I have chosen a very simple example, but I think that it will cover more or less all the
exactly, as long as all the steps are covered.
And I mean, of course, you can employ days and days playing with Selena, but
exactly.
So
thank
okay,
you,
Dina.
thank you very much for organizing.
See you tomorrow.
See you. Bye bye.
Bye.